Alrighty, welcome back to another video, guys. Today I'm going to show you guys an example of what we would use the molarity equation for, and how that we can combine that with a little bit of stoichiometry in order to just do a little bit of application of chemistry here. I've got my gloves on, got my goggles on, but I'm not doing a face reveal for any of these videos. So let me just show you what I got here. We got a burette. This is something that uses these tick marks to measure, I'm sure to some degree of accuracy, the volume that we would be measuring of, in this case, sodium hydroxide that's going to go into this burette here, so that we can measure the amount of sodium hydroxide needed. I've got this says 0.5 molarity hydrochloric acid. That's not right. I'm going to relabel this here in a moment, but I'm not exactly sure how much molarity is in this, or what the molarity of this hydrochloric acid is. So that's why we're going to do this titration, where I put sodium hydroxide into this burette, puts about, I think, 25 milliliters of hydrochloric acid into this beaker, and then using this stuff called phenolphthalein, hope I said that right, we're going to take this stuff, we're going to put it into this beaker, and just like a couple drops of it combine it with the hydrochloric acid, and then slowly drip sodium hydroxide into the hydrochloric acid filled beaker to figure out what the molarity is of that. I need to set this camera down to get this set up, so I'm going to do that really quick. Okay, back. Got 50 milliliters worth. I think that's about right. Yep, 50 milliliters. Yes, 50 milliliters worth of sodium hydroxide into this burette here. We're going to use this to slowly drip down until we reach, well, just until, I guess is the word, until it gets down to a point where the hydrochloric acid that's about to go into this beaker right this second turns neutral. Turn that here. And to make this go a little bit quicker, I'm only going to use about 25 milliliters. I'm confident that this is going to be less than 1, but we're going to slowly add. Let's see here if you guys can. So close. That looks about as close as we're going to get to 25. And I'm okay with that. All right. That's got some hydrochloric acid into it. Now let's go ahead and get some phenolphthalein in it, and that's a pH indicator. Take a little bit of my pipette. Boom, got just a little bit, and we're just going to put a couple drops in. That should be good. That might be a lot. Yeah, I'm okay with putting it back in. That's okay. Okay, give that a quick stir. And there we go. Yep, boom. Got it all set up. All right, now I'm going to slowly drip this into this beaker here. And if you guys can kind of see into there, let me see if I can zoom in. You can see that there is a pink color, purplish pink color. Let me know if you can tell me exactly what that is. That starts to form in there. And When that turns, the moment that turns completely pink, that is about the moment where the liquid inside there has turned, started to turn basic, I guess. It turns to an 8 pH. So once it reaches an 8 pH, that's pretty darn close to neutral. This is sodium hydroxide. This is a fairly basic substance, like approaching 13, 14 on the pH scale, depending on the molarity concentration. When this goes basic, it's going to go basic really quick, just even by adding a couple drops. So we will know then that it's neutralized, and we'll have a pretty safe estimate as to what the molarity is, and we can kind of use that as a gauge for our chemical reactions for hydrochloric acid. After we've done our stoichiometry, of course. Just let that keep slowly dripping. We're getting close there. At some point, this is going to have to slow down. If I had the high-tech equipment, I would have the stir bar in there stirring, but we don't have that. Careful. We are up to 18 milliliters now. Milliliters. And I'm going to start slowing it down a bit. This is going to kind of like a light flicker on and off. So I'm going to go like 3 drops at a time. Like that 4. Keep going. And then right now, what's happening is phenolphthalein is binding, the pink that you see is phenolphthalein binding to the sodium hydroxide. The reason it's going away is because the hydrochloric acid is reacting with the sodium hydroxide, and there's no more sodium hydroxide left for the dye, the pH indicator, to bind to make it that pink color. So when there's no more sodium hydroxide, there's nothing for that pH indicator to bind to turn pink, and so it turns clear. When there is an excess of sodium hydroxide, and it only takes about a drop to get a pretty high excess, at least with this 1 molarity, it'll stay pink, and you can kind of see that it's getting a little bit closer there. I'll go 5 drops. It's getting close. Back out of it so you guys can see what I'm doing. Ooh, that was not even a lot there. It all went away. And I'm just slowly adding a couple drops at a time. I'll zoom back in for you guys. Zoom back in for you. Okay, we're at 22 milliliters. Oh, did we hit the pink? I think we did. Awesome. So right now we just hit 8 pH, or a pH of 8. as a fair estimate, that took 22 milliliters of sodium hydroxide. So let's go ahead and go do some math now. You guys see that okay? Yeah, it is a pretty pink color, isn't it? So for 25 milliliters of hydrochloric acid, it took 22 milliliters of sodium hydroxide at 1 molarity to neutralize. So we can use this information now to find the moles of sodium hydroxide that were used, and then use those moles to figure out the hydrochloric acid amount of moles is in that solution, and then use that information to find the concentration of our unknown hydrochloric acid. Let's go ahead, go back to the whiteboard, do some math. All right, welcome back. We are going to continue this. We're going to use this information now to figure out what the molarity was of our unknown hydrochloric acid. We knew that this was 1 molarity. We knew that because, well, I knew that because I made it from scratch. So I put 40 grams of sodium hydroxide into just under a liter of sodium of water. So that came out to about 1 molarity. And we can use this information now to figure out how many moles went into there, figure out how many moles that reacted with hydrochloric acid, and then we can use that information to figure out the molarity with this here. So in order to figure out the number of moles used, we take the molarity equation, M equals N over L, and we'll plug in the information for sodium hydroxide into here. So we got to find moles. We know the liters, and we know the molarity. So 1 equals N over 0.022 multiplied by 0.022 to both sides over here as well, and that comes out to, well, it's 0.022 as well. So 0.022 moles. This is liters. This is liters. Has to be in liters. You can't just use milliliters. So that's something to make sure that you're aware of when you're doing these calculations, that if you're doing them in milliliters like we so commonly do, you have to convert it to liters in order to get the accurate molarity. Otherwise, you will end up with, I believe it is much smaller molarities. Well, you'll have moles per milliliter, I guess, and we measure molarity in moles per liter. So it'll be different. It won't be accurate to chemistry standards. We got the number of moles here now. Now we can use these number of moles here to figure out the number of moles for hydrochloric acid that was in that 25 ml sample. So we had 0.022 moles here. This is a 1-to-1 ratio, so there's going to be the same number of moles here that were in that 25 ml sample beaker as there was that was used up in 22 milliliters here. And then once we figure that information, same thing. Molarity is number of moles per liter, so we have 0.022 moles in 0.025 liters, and so we just plug that in, 0.022 over 0.025, and then calculator that. And that comes out to 0.88 molarity, give or take, depending on sources of error, significant figures. I only roughly measured that, but this is good enough for what we do. And we don't care about that stuff. All right, thank you so much for watching today's video. I hope you found this helpful. If it was helpful and you liked the video, please leave a like and subscribe to the channel. It helps a lot, and I will see you guys all in the next one. Take care.